Oh, yes. It's Brady.
Caw.
And Levi.
Levi.
Do the bird noise.
Caw.
Caw.
Nerdish.
It's nerdish with a 3, not nerdish with an E. Why?
8 to 9:30 p.m. Tuesday, Wednesday, Thursday.
Yes, because nerdish with an E was taken.
And that's why we do it 8 to 9:30 p.m. Tuesday, Wednesday, Thursday.
Thank you for giving that reason for a question that I didn't ask.
That's sort of like the way we eliminate answers on the reading section.
Yeah, that's true. And I guess the other sections to a certain extent.
I think it's important when doing a rap to listen to the beat that's happening in your ear. Otherwise, you have a problem staying on beat.
Correct. We do the ACT and SAT, they're standardized tests to help you get into college.
We don't tutor rap. We shouldn't ever do that.
No, we're not pretending to be tutors of rap, even though we're really good. Sometimes you can be really good at something, but not be a good teacher. Case in point.
Point in case.
Point in case word.
Point in case something bad happens.
Like this?
Yes.
I think we're enriching your lives by you watching this.
I'm getting a phone call from a friend. Do you think I should pick it up now?
The phone call just was dropped. Maybe he'll leave you a voicemail.
Next time, I'll pick it up during the stream. That way we can all talk to my friend Steve.
If you think this is not very high quality, don't worry. We're gonna do it again in 2 weeks.
Also, we're much better quality when we're teaching you all the things in a number tree.
Like prime factorization?
Yeah.
Oh, that's fun.
Yeah.
You break a number down into its prime parts until you can't break it down
We
anymore.
can probably do that right now.
Yeah, we can.
Okay, so let's say 32.
I was going to say 30. That's so close.
Oh my gosh.
All right, break it up.
Okay,
Any way you want. 2 and
okay,
16.
Okay, 2 and 16.
2 and 16. 16 is 4 and 4.
Okay, 4 and 4. Oh,
And
interesting.
each
So
4
16
is
the perfect
2,
square.
2. Yeah, exactly.
Okay, 2 and 2 and 2 and 2.
So it's 2 to the 5th.
Yeah, it's 2 to the 5th.
2 to the 5th, exactly.
Whoa.
Yes.
That's pretty cool.
You see that? It's that quick. Now you know. Think about that for our whole show.
Now stop watching the stream because you've learned everything necessary.
Bum, 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 bum. We're in a box. You can help us by asking us questions in the hope that someday we can escape. Hey, Eric, we're sorry about that. Levi did something where I think he had the lens cap on and we had to take it off.
Yep, I had it on.
You can't leave the lens cap on.
Nope.
Can't do that. Eric, it's good to see you, man, or at least see your Twitch handle up there. Is that what you call it, a Twitch handle?
Yes.
Handle?
And look.
Good.
Very good.
All right, I'm Brady.
I'm Levi.
I'm Brady.
I'm Levi.
Occasionally, I'm Charles. I was Charles earlier today, actually.
Charles.
Yes. I really was. I'm not lying. I made a class call me Charles
Why?
because I was substituting in for a guy named Charles. They combined our classes, and I said, for those of you in my class, continue to call me Brady. For those of you in Charles's class, call me Charles.
Nice.
I made them call me Charles. Yes. All right. All right, all right.
Bray's doing inequalities. I am doing vocab and context. So,
You mean contextual vocab?
Isn't all context vocabulary?
I don't know. If you're into that sort of thing.
Yes.
I hope so.
Okay.
I got a couple of viewers. That's fun.
Oh yeah.
Yeah, I love viewers.
Just don't look at it.
Yeah.
Ow.
Why did you do that?
I didn't mean to. It was a transfer of electrons between my finger and your chest.
Okay. I guess that's okay. All right.
Eric, what do you think?
Yeah, Eric, tell us your thoughts, your feelings,
Thoughts?
innermost dreams, suggestions.
Daydreams.
Absolutely.
Night dreams.
Okay.
You can buy 5 or less hot dogs
Scoot over.
Technically, it's 5 or fewer.
Because we're talking about hot dogs specifically? No? We're not going to talk about that?
All right. I don't remember math topics, so I see a problem. Good.
That's good.
5 or fewer. Fine.
Okay.
Yeah, whatever.
Where's my ring ding, my yodel?
Here's the situation. You're at an old ball game. You can buy 5 or less, 5 or fewer hot dogs. It sounds weird. 5 or fewer hot dogs.
Hmm?
I mean, you wouldn't say I have less hot dogs. I'd have fewer hot dogs than you. Yes, but when you're doing 5 or less, 5 or fewer.
If you say there are 5 or less and you're talking about numbers and just mathematics, 5 or less. Less than 5. But we're talking about hot dogs, clearly.
All right. So let's just make this a very simple inequality. The reason why we have inequalities is because a lot of times in math, the answer isn't just one number. It's just related to a certain number. So it can be larger than a number or less than a number. So in this case, you have enough money so that you can buy 5 hot dogs if you want, but you can also buy less than 5 hot dogs. No one's making you buy or fewer hot dogs. No one's making you buy these hot dogs, okay? But you can. So if H is the amount of hot dogs you can buy, we got 4 options here. Less than, greater than, less than or equal to, greater than or equal to, and then of course we're going to have 5 here. So can we buy 5? Yes, we can. They say we can buy 5. So that means we have to use one of the equals inequalities. These ones tell us we can actually be equal to something or less than it or greater than it, okay? Now, 5 or fewer hot dogs means less than 5. So we want to use the less than or equal to, which is this one right here. Narradish is now streaming. Thanks, Stream Elements. All right, that is the inequality we want to use. That's right, Eric TLT. Well done. H is less than or equal to 5. You can have 5, you can also have less. All right, let's see what that looks like on a number line. All right, we got a number line. It's orange. Most number lines are orange. They've done studies. Here's 0. Here's 5. Your first question is, should it be a closed dot or open dot? We can actually be 5. That's okay. So we're going to use a closed dot at 5. If we couldn't be 5, we'd have to use an open dot. And then we can go which direction? Less than 5. That is towards the smaller numbers. So we're going to go this way. Now, I had no restrictions on... Exactly, good job. I'm pretty good at these. Yes, you are, Eric TLT. Yes, you are. Yes, you are. Good. Eric loves hearing that. I didn't give you a restriction on how low we could go, so technically you could go lower than 0 if this is all you had to graph. Now, this is reality. You can't buy -1 hot dogs unless you're the vendor and you're giving away hot dogs, because then you're losing hot dogs. But if you were the vendor, you'd probably want to buy hot dogs when you run out of hot dogs. That's a different situation. We're going to throw in one more thing. H can be greater than or equal to 0. All right, so we're going to stop right at 0. Yeah, we can't have less than 0. So we're just going to forget about that situation right there. All right, we got a fun little squiggly. Doesn't need to be a squiggly. You just need to shade in that region between those two things. Okay? Fantastic. Fantastic. Let's change this up. Let's say, okay, you must. No. No.
You must.
Oh my gosh. Oh my gosh. Greater than 5 hot dogs or more than 5 hot dogs?
More. Greater is uncountable as well.
I can count greater.
No, you can't.
All right, situation has changed. You must buy more than 5 hot dogs. That is a command. Someone is giving you a command here. So H, let's think about H. Number of hot dogs we're going to buy. Can it be 5? No. That's right, Eric TLT. H is greater than 5. Eric TLT, open dot or closed dot? Open dot or closed dot? Open circle to the right of 5. Yes. Well, the circle would be on 5 itself, but then we sketch in to the right of 5. Yeah. So we put the open circle directly on 5. But because it's open, we know we can't actually have 5. Yeah, this kind of goes on forever. So if you wanted to buy 1,000,000 hot dogs, that'd be fine. That's more than 5 hot dogs. It's not exactly 5 hot dogs, it's more. That's very exciting, all right? That's what they mean. Not too difficult. Solving inequalities, on the other hand, really, really difficult. No, it's not, but it's just one rule you have to obey. Otherwise, it's very simple, very similar to algebra. I'm just going to get rid of this side. Okay. Yes. There we go. So Levi,
Yes.
I was at a baseball game last summer.
Were you?
Yes, a Cubs game. And my friend and I decided to make the opposite song to take me out to the ball game.
Okay.
So it was like, bring you in to the square business, bring you in to the lack of people, sell you no peanuts or Cracker Jacks. I care greatly if I do get back, because it's boo, boo, boo for the away team. If they win, it's a pleasure. For it's 3, 2, 1 ball, you're walked at the new square business.
That's good.
It was fun.
That's very helpful.
My favorite part is the new square business. The opposite of old ball game. Okay.
That's ideal, Bert.
Yes. Oh, it works very well. Yeah, people are pretty excited about it. All right, let's try to solve something. All right, 2x plus 5 is greater than 4. These work just like equations. So whatever you do to one side, you do to the other. It's just manipulations. There's only one caveat, which we'll get to. So if we just want to solve this normally, we treat this like an equal sign. We have to subtract 5. 2x is going to be greater than -1, then divide by 2. So x is greater than -1/2. There you go. Got my pencil and paper. Very good. You're going to need those to do some calculations. That's normal. The thing that's not normal is when you're solving an inequality and you have to make a move that is either multiplying or dividing by a negative number. When you do that, you have to switch the direction of the sign. All right? If we had -5x is greater than or equal to 15, we have to divide by -5, which is dividing by a negative number. So when we write this over again, this is going to now be facing the other way. And this is going to be -3. X, yes, switch signs. You got it. But don't switch cosines. No, different area of math. Please don't get those confused. Signs and signs would be homophones because they sound the same.
Yes.
Yes. Very good. Yeah, all right, so that's solving inequalities. It's really that easy. So the one thing you have to keep in mind is if you divide or multiply by a negative number, you switch the sign. Everything else, you just keep everything the same and just do the same thing on both sides like you normally do. I'm in trig, LOL. Yeah, you are. Yeah, you are. Are they calling you Trig Eric? Is that what they're calling you these days? Because if I knew you, Eric, I would call you Trig Eric. In fact, I kind of do know you because you're watching the stream, so I will call you Trig Eric. That is your new name. It is now Trig Eric. Very good. Okay, so that's simple linear inequality. No, not linear. That's one-dimensional inequalities. Now we're going to talk about linear inequalities, and it's about to get really funky.
So funky.
Yep. Funky, 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 funky. Everybody clap your hands. Clap, 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 clap your hands. Clap, 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 clap your hands. All right, now we're going to do the basic step. To the left. Take it back now, y'all. One hop this time. One hop this time. Slide to the left. Slide to the right. Crisscross. Crisscross. Cha-cha now, y'all. Turn it out. All right, I'm done. With the song. There's a Charlie Brown somewhere in there. Last time to get funky. Just kidding. No. There will never be a last time to get funky. Well, I guess there is.
Why not 3, my lord?
Depending on how long you live. There will be a last time to get funky. And depending on what you think happens after you stop living, maybe there's more time to get funky. Maybe that's the best time to get funky. Everybody clap your hands. Clap. Clap. Okay. Let's talk about something. Yeah? Y is less than negative 2x plus 6. We've got our coordinate plane now. Oh man, I love that noise. That's so good. All right. So what you want to think about for this, very bottom right of screen, over here, a little bit of this. Is that good? Is that what you want? Did that work? Unless a reflection. Maybe, I don't know. Hey, don't worry about it. Okay, so the question is, you can either have a dotted line or a solid line to represent this line right here. And it has to do with the same thing that the open dot and the closed dot have to do with. Can you actually be on the line? If you can be equal to the line, you want a solid line. If it's only less than or greater than, you want a dotted line. So in this case, we want this to be dotted. You're going to put a dotted line exactly where you'd put a normal slope-intercept line. Y is equal to negative 2x plus 6. You just put a dotted line there, okay? So the way we would graph this, our y-intercept is 6. Put that right there. And then our slope is negative 2. So we go down 2 over 1. So we're eventually going to get to, if I'm not mistaken, 3 is what we're going to get down to. Yes. So this thing is going to look like something amazing. Oh, well, hold on. Hold on. And then dotted. Don't forget that it's dotted. Not the best dotted line I've ever drawn. I will admit it. I'll be the first to admit it. No one else has seen this except for Levi, but he's not paying attention. It's a dotted line, but we're not done yet. Because like inequalities on number lines, you point in a certain direction. The points that satisfy this inequality are going to be on one side of the line or the other. There are different ways of figuring out which side it's going to be on. One method, which I'll tell you first, then I'll tell you the method that I like a lot. One method is to put in a test point and see if it works. The test point that really helps is 0, 0. It's the easiest to work with. So the point 0, 0, would that make this inequality true? Let's think. 0 is less than 0 plus 6, which would be 0 is less than 6. That is true, which means everything on that side of the line is going to be shaded. This is all good. We like this. We like this. All right, it's shaded for infinity, just always to that side of the line. Okay? This is not a good marker, Levi.
Wait.
It's not good.
Does that help?
What did you... What?
I gave it some time.
No.
Okay.
It's done. It's done. Nice. Now there's another way to do it, which I like a little bit better. All right? Less than. That means down. Greater than means up. Less than means down. So we have to shade underneath the line. So go to any point on this line and then make a little down arrow. That's the side of the line you have to shade. So you could think of this as left of the line, right of the line, but you can also think of this as above the line and below the line. Y is less than, Y must be down. All right? You can also do that. And that's what I like because it's very simple. I like things that are simple. Like Levi. He's very simple.
Simpler.
There you go. That's right, Levi Simpla.
Yeah.
Very good. Very good. Let's try another one. We're going to have y is greater than or equal to x squared minus 3. Ooh, we can do not linear stuff. Yeah, of course we can. Who said we can only do linear stuff? It wasn't me. It wasn't me. Okay. Never going to say the words to that song. Let's see if this is a good... Oh, yeah, this is better. Absolutely. All right. Dotted or straight line. Not straight, sorry. Dotted or solid line. This is an equal to 1. It's going to be a solid line. Okay? X squared minus 3, what does that look like? Well, it has a slope, sorry, it has a y-intercept of negative 3. All right, so it is going to hit the y-axis at negative 3. How do I know that? Well, the y-intercept is where you're at when x is 0. If you put 0 in for here, you just get y negative 3. So we're definitely going to be there. This is an upwards facing parabola, and it's going to be a solid line. So it's going to look something like this. It's actually a pretty decent parabola there, if I don't say so myself. Next question, the shading. Where do we shade? Y is greater than, you shade up. That's it. You shade up. Pick a point, go upward from that point, and you'll realize that you are inside the parabola. That's where we're shading. So this parabola goes up into infinity, and the shading on the inside also extends into infinity. All right? Very exciting. We're all getting into this. It's super fun. What about systems of inequalities? That's where things get funky. Funky, funky. Everybody clap your hands. Let's try adding a line to this. Y will be less than negative x plus 2. We're going to put that on here. So first thing I'm going to do is I'm going to get rid of the shading, but we're going to keep the parabola. So we're going to imagine that we have both of these inequalities at the same time. We have to satisfy both of them. Okay. I'm generally happy with that. So this is going to be dotted. What about less than? Outside of it. You're right. Good job. If we're less than, we draw downward, which means we're drawing on the outside of the parabola. Very good, Eric. Very good, Trig Eric. Trig Eric. Chop, chop, chop. A lot of chopping. Dotted line, because it's less than. It's not equal to. It's less than.
You're such a doofus.
Me?
Yeah.
No.
Yes.
No, I'm not.
Yes, you are.
We're going through the y-intercept of positive 2. We have a slope of negative 1. And it's going to be dotted. You call me a doofus?
Yeah.
Why? Fantastic.
You are, sir.
All right. We're going to shade. We're going to shade less than. It's going to be below that line. But here's the thing. This is a compound inequality. Nah, no, it's not. It is not a compound inequality. It is a system of inequalities. We need to shade where it satisfies both inequalities. We already know that inside the parabola satisfies this top one, but what about this bottom one? We would want to shade down from this line, which normally we would just shade below this line everywhere. But that's not going to work because we can only shade where they match. And that's going to be right here. Inside the parabola, under the line, gives you that right there. All right? It's extremely exciting. Actually, when I was walking home from work today, everybody on the street was talking about it. So that's how I know it's exciting.
Did you talk about just picking a point and seeing if that satisfies?
Yes,
the point?
I did. I did. Talked about using 0, 0. Thank you for checking now. Okay, last thing we're going to talk about is absolute value inequalities, how to solve them. So 4 times x minus 2 in absolute value plus 3 is less than or equal to 15. Okay? First thing you do is treat this like a normal equation. It's an absolute value equation. So when you're solving an absolute value equation, your first step is to isolate the absolute value expression. Don't worry about x yet. The absolute value of x minus 2, get that by itself. Think of that as a variable. Try to solve for that variable. We want to subtract 3. So let's do it.
Why not 3, my lord?
It is 3.
Oh,
Yeah.
my
So,
lord.
there you go.
My lord.
What? I'm your lord.
My lord.
What is that, heartbroken peasant? Okay. Divide by 4. And we get absolute value of x minus 2 is less than or equal to 3. Now what? If you are an expert at absolute value, you know that from here it branches into 2 different equations. Ah, Eric TLT, not exactly. It's not that we switch the plus or minus in here. It's that one equation is going to become x minus 2 is less than or equal to 3, and the other one is going to be x minus 2 is greater than or equal to negative 3. Okay? There are 2 things going on here. Eric TLT, it's not the plus or minus that you switch. It is this number here that switches. Okay? Not only does that switch, when it does, you have to switch the signs. So one of these looks identical to what we had, except just no absolute value. The other one will look identical until we get to the switch sign and, as in the switch inequality sign, and the switch number sign. And and then we solve both of these. So in order to solve this one, I have to add 2. X is less than or equal to 5. In order to solve this one, I have to add 2. X is greater than or equal to -1. All right. Now, what does that look like if you put it on a number line? Because there's 2 different conditions we have to satisfy. We have 5. We have -1. And then this would be 0. We have to be greater than or equal to -1. Close dot, going that way. We have to be less than or equal to 5. Close dot, going that way. So what we're going to end up with is an in-between here. It's going to be in between. Eric TLT. Absolute value. Do you know how to solve a normal absolute value equation? Because that's going to make this make more sense. This is like a double layer of complexity. Absolute value normal equations, you have to know how to solve those for these to make sense.
Allow me, my lord.
You want to?
Yeah.
Okay. Now the other thing that might happen instead of getting between 2 points is you might have 2 points and the solution's outside of them. All right. Levi will now demonstrate to you how to solve absolute value equations.
So we're going to start with this guy right here. Same deal. You're treating them the same until you get to the split point. So we're going to multiply by -2 on both sides. And divide. Oh, huge mistake, Bird.
What?
Ruined everything. This is why I don't tutor kids.
Yes, you do.
Oh. I apologize. Huh? How's that look? Not great. Whatever. So we're going to divide by -2. And we'll get x minus 4 in absolute value is less than or equal. Oh, no. So now we have to switch the sign. So with absolute value stuff, anytime there's a negative involved with multiplication, division, or getting rid of absolute value stuff, you flip the sign. Okay? So now, we divided by -2. So we're going to have to flip the sign to greater than or equal to. And this is still going, and now this is -3 divided by -2, which is 3/2. Let me know if that doesn't make sense. Then from here, we split this into 2. It's good. This way we're splitting vertically and that's horizontally, because why be consistent? So we'll get x minus 4 is greater than or equal to... Wait. Okay, I'm so sorry. I'm very sorry. Genuinely very sorry. We're just doing equals. That's all we're doing. My bad. Okay. We're just doing equals. I'm very sorry. Right? You wanted me to just do...
Yeah.
I don't know why I did that. Okay. So here, we're still going to split. The idea is, whatever, absolute value, right? It just takes whatever's inside it and makes it positive. If it's positive, it stays there. If it's negative, it becomes positive. So we know that no matter what's in here, it's going to be either 3/2 or -3/2. It has to be one of those two things. So you just say, well, I'll take what's in there and I'll say, this was foolish, that this x minus 4, it's got to be 3/2 or it's got to be -3/2. That's just what absolute value means. And then you solve each of these. So this becomes x, just draw an arrow. X equals 3/2 plus 4 is 11/2. And then here we have x equals, we add it, so we get 2.5, which is 5/2. And those are our two answers. So, as Brady said before, with absolute value, anytime you have absolute value and your variable is inside there and you want to solve for it, isolate the absolute value symbols and then split. When you split, you make the other side negative in one of the cases and then just leave it as it is for the other. So here we just moved it over there, got rid of the absolute value. Here we moved it down, we took the negative of this thing, because it could be that. Here, and then we can go back to Bird if you want to do this now. Okay. Any questions on that with just equal signs? Split once you've isolated your absolute value. And split goes positive and negative on the non-absolute value side.
He says it does, right?
That was a little while ago.
Oh, okay.
Yeah.
Stop it.
Stop what?
Stop doing what you're doing.
Down.
Ow!
Sorry.
That hurt!
I didn't mean to.
It really hurt! You do condone violence.
No, I don't.
That was where you snapped it.
I didn't know it would happen.
Violence is supposed to be just like this.
Oh, that's what violence is.
Yeah. Haven't you ever been in a violent area where they just do that?
Yeah.
That's what they do. All right, we're done with this.
I'm so sorry.
No, you didn't know. It's okay. You didn't know.
Yeah, I couldn't have known.
There's no way you could have known.
Well, you want to come back to this now?
Not really.
Okay, so this is the same thing as that, but with inequality stuff, you always switch the sign when you have multiply or divide by negative, or when you do that split. I'm sorry, Bird.
You didn't know. It's fine.
Well,
If you had known, you wouldn't have done it. Am I right in saying that?
yes.
Yes. Good. And we have no problem here.
So you're finished.
Yeah, I'm finished.
Dude, you never use enough water.
What are you talking about? That's the opposite of what you usually say.
Oh. Okay. Ooh. We are going to do vocab in context now.
I love that.
Do
Wait,
you?
hold on. We gotta get rid of this. There we go. Very good. Very good.
Eric.
Yes! That's right. Peace is greater than violence. Violence is less than peace. The opposite of war isn't peace, it's creation.
What?
It's a line from Rent, the musical.
Doubt it.
No, it is.
Hey, Eric, how do you normally approach the vocab in context questions? So, these bad boys. So number 3, right here. As used in line whatever, this phrase or single word most nearly means this. How do you normally tackle these? Do you take all the answer choices and plug them in and see which one sounds the best? Or do you do something else? Do you just skip these? Have you ever seen this before?
What do you do? We're so curious. We don't condone violence.
No. In this question,
Very good. Very good.
plug them in, plug them in. Very nice, Eric. Bird. Eric said plug them in, plug them in.
When no one's around you?
Yeah. Okay, unfortunately, Eric, that's not quite what you should do here. Okay? You look at the line numbers, you figure out what words you're replacing, and then you ignore all the answer choices, and you try as best you can to ignore the original wording. You just need to know where it is, and then don't think about it. Okay? It's called vocab in context for a reason. The SAT used to have just straight SAT vocab, and you had to know what the words meant. Here, you don't need to know what this means, and knowing what this means, or thinking you know what it means in context, is sometimes a mistake, or it can lead you to mistakes. Because all of these answer choices do have a relationship to not readily verifiable. But so that's why you shouldn't go from backwards to front. You don't want to go backwards. You want to go forwards in this, which means you want to start with the line numbers and replace. So lines 1 to 2, so let's do that. Okay, up here. My emotions are complicated and not readily verifiable. So, this is what we're replacing, and I'm going to cross it out because I don't want us to read it. We're talking about context here. That is what they're testing you on. They're not testing you on your vocabulary so much. They're more testing you on your reading comprehension. So, there will be context here that helps you figure out what words these need to be. They're not just going to say it and leave you hanging. This says, my emotions are complicated and this other thing. That doesn't mean that what we just took out means complicated, because this guy's emotions, whoever this is, are complicated and something else. You're going to look for definitions of what you just took out around your word, or words in this case, and you're also going to look for opposites. In this case, I think it's definition. So my emotions are complicated and blank. I feel a vast yearning. So that's his emotion. I feel a vast yearning that is simultaneously a pleasure and a pain. So that seems like it connects to complicated. We have, I'll do this in orange. We have pleasure and pain, and that's complicated, right? Because you have conflicting emotions. And then we have, I am certain of the consummation of this yearning, but I don't know yet what form it will take, since I do not understand quite what it is that the yearning desires. Okay, so now this guy is saying that he doesn't get it. That's what he's saying. So my emotions are complicated and blank. It's pleasure and pain, and I don't get it. That is the context that you have to use to answer this question. So it's just, I don't get it. The emotions, specifically. Okay? That's what we just defined this word as using context. There is always context. That's the point of the questions. So now, oh boy, where did I go? How did I get so far ahead? This is what I want. Yes? Okay. Let's see which of these answer choices this goes to. Unable to be authenticated. No. Likely to be contradicted. Not quite. Without empirical support. That seems a little bit unsupported. And then not completely understood. I would say D. Okay? We did not use the words, good, yes, not readily verifiable. We didn't use them. I'm not saying you can't get this question right without doing what we just did, but I am saying that it's very easy to get caught up in what these other things might mean, because then you're thinking, okay, I'm going to connect you before you even go to the passage. You're starting to think, well, does not readily verifiable mean unable to be authenticated? Yeah, it does, without context. Give yourself the context first and then come back to the answer choices. Okay? So let's do another one of these. No. No, okay, so nothing else here. Okay, we got take the slightest interest in. Also, I don't know if the answer is A, it's just circled. 7. Oh, 7? Really? Did I miss it? Okay, so that's not quite vocab in context, right? Because they're not asking you what is a synonym for the word that we used in this context. It's just asking us to describe something. So that's not what we're working on. But I'm happy to do that. I just haven't read this passage in a while. Okay, number 8. No, sorry, number 9, right here. And I'm going to erase that. As used in line 49, take the slightest interest in. Okay, so that is what we're replacing. I'm not going to read the answer choices at all. It's not the point. And I may make a mistake as a result. Who knows? Okay, 49, take the slightest interest in. Oh, come on. Okay, so 49 over here. Take the slightest interest in. So we have, no one but a Swedish madman could take the slightest interest in it. Okay, so this is what we're doing. I like the word madman, that seems interesting. Could take the slightest interest in it. Take the slightest interest, I think, is it. Okay, so let's look around for what's going on here. Let's just start at the top here, or at the top of the paragraph. And suppose you were to find it in spite of all, this wonderful place that everybody is so anxious to stand on. What would you find? Exactly nothing. A point precisely identical to all the others in a completely featureless wasteland stretching around it for hundreds of miles. It is an abstraction, a mathematical fiction. No one but a Swedish madman could take any interest in it. Here I am. The wind is from the south. Okay, so no one but a madman. So we're talking about a madman would do this, right? No one but a madman would do this thing. So we're talking about a thing that doesn't make any sense. So I'm going to write that down. No sense, or madness, or whatever. And then, thank you, Britt. And then also we have, whatever this thing is, it's boring, it seems, right? There's completely featureless. I like, that seems helpful, so that's what we're describing. So something featureless, it's a wasteland. That's important. hundreds of miles. It's an abstraction, a mathematical fiction. Okay, so it doesn't exist, sort of. That's the point, and we're describing it. It's senseless to do this thing, and it's some sort of verb. So that was a lot of stuff, probably too much. Who knows? Ignore that number 7. Wait, what? Oh, yeah, sorry. Yeah. Okay. So we have, from over there, we had no sense. And we had a verb describing that, like doing something to this really boring wasteland of a place makes no sense. So, accept responsibility for. I don't think responsibility is involved here. Possess little regard for. Okay, so we got to be careful on this one. I got to talk about something else now. Pay no attention to. And then have curiosity about. Okay. We need to be careful of this, because there is a negation in this sentence that makes it dangerous. Nobody but a Swedish madman would take the slightest interest in it. So, but we're just talking about take the slightest interest. So it's not going to pay no attention to, because that's the opposite, right? So the idea of the whole sentence is nobody but a madman would pay attention to it. But saying pay no attention is not what those specific words, take the slightest interest in, mean. So pay no, I don't like the word no. That is the wrong negation here. So that they jumbled up, they just did the opposite. So possess little regard for and have curiosity about. Okay, so we're talking about something that makes no sense and something that's really boring. Regard is not quite the right word here. It's close, but possess little regard for something, the connotation of that word is respect. There is some sort of emotional component to it, and that's not what we want here. We just want curiosity or not, because we're talking about what I had circled over here, and I'll go back to it. What have I done? Okay, yeah. Completely featureless wasteland. That has to do with curiosity more so than it has to do with respect, with regard, sorry. So D is good, yes. These are hard. They can be confusing at the very least. Okay, let's do number 10. As used in line 50, bearing most nearly means, and again, you don't know how to you don't have to know how to pronounce these words. You don't have to know what they mean, at least the original word. All you need to do is find it and replace it using context. We're looking around for context. So, yes, number 10. Line 50, bearing. Is it on this page? No. Oh, it's right after. Yeah. Here I am. It's an abstraction. Know about it. So a madman, take interest in it. Okay. Here I am. The wind is still from the south, bearing us steadily northward at the speed of a trotting dog. Okay. So what is going on here? Our word is bearing, so let's cross it out and see what its role is and what helps us identify what it's supposed to say. Bearing us steadily, so it's a verb, great. So I'll cross it out. Yeah. Bearing us steadily, or blanking us steadily northward. So the wind is still from the south. So it's wind, and the wind is doing this verb. So the wind is doing something to us. Yeah, pushing, forcing. I don't know about force necessarily. For pushing is fine, bringing is fine. Forcing is a little strong, because that implies that we're resisting, and that's not shown here. Yeah. So bearing us steadily north, but maybe that is the answer. We'll see. So pushing, bringing pretty run-of-the-mill words, but that's what we're trying to say. There's not a lot of emotion tied to this word at the moment. So in number 10, we have carrying, affecting, yielding, and enduring. Well, wind doesn't endure people. That doesn't make any sense. We're talking about wind doing something to this, driving us north. Yeah, driving is pretty fine. Okay, so enduring is no good. Yielding doesn't make sense. We're not. It's a verb, and it's being the wind is bringing and pushing. It's not yielding. Affecting. Yes, the wind is having an effect, but it's bringing us north. So it's not affecting us north. That doesn't make any sense. It's just carrying. Yeah? I'm not saying you can't figure it out by just plugging in, but don't plug in. It's not that useful. A. Perfect. How much of a lag are we on?
Plug it in, plug it in.
Okay. That's vocab in context. Again, affecting us to go north, not affecting us to go north. Us north. Yeah, it just doesn't quite work. Okay. I don't think it would. Effect is, you wouldn't say that. Effect kind of does its own thing, right? It had an effect. It affected us. It had affected us in a way that did this, but affected us to go north. That thought process doesn't really work in my head. But we have carrying, which is great. I think they're on a boat or something. I also may have made that up. Okay. I think we're good here. So, Bird, you got to leave in 10-ish minutes, right?
Yeah, I think so.
Okay. Do you have any questions for Brady specifically? Oh, yes. Okay. Let's knock that out real quick.
What did they ask?
Effect versus effect.
How did I know it was going to be that?
How did you know that, Bird? Are you a wizard?
Yes.
Sarah?
I am a wizard. Yeah. Hi, yeah.
Wizards go high, yeah. Yeah, that's right.
Well, only when they identify themselves as wizards.
Effect.
It's customary.
Effect. They are homophones, right?
Yes.
Okay. This is a noun. This is a verb. For the purposes of this test, this is what's going on. He affected me. Or let's go with it. That makes sense, just a little bit more normal to say. It affected me. It had a strong effect with an E on me. This is a noun. This is the verb of this sentence. That is the difference between effect with an E and effect with an A. Also, effect with an A, when it is a noun, it means your face or the way something looks.
And it sounds like affect.
But it's pronounced affect. So if you hear the SAT pronounce it affect, you know that that's what they mean. The way something looks. But they will not make you do that. I've never seen anything like that. They'll make you choose between effect and effect as a noun and a verb. This is what we care about. Okay? Any questions on that, Eric?
Question.
Yes, Bird.
What's that thing in the corner?
Oh, well, Eric just asked a question. I'll go with his. So you can rewrite the sentence into past tense to make it affected, but not effected as... Right, yes. So just think noun versus verb. So it will have no blank. Which one do you want there? And let's say we want to, no, that's confusing. I won't do that one. We can do the blank was immediate. Yes, that's effect with an E. Next one. And then we have that one, and then let's do his words blank her. His words had no blank on her. Let's go with Diglett's mudslide was super blank. This is effect with an it's effect with an E. The effect was immediate. This is a noun because it's the subject of the sentence. This is your verb here. And then we have his words affected her, or his words affect her. Either way, you don't have to make it past tense. This could just be present with an A. His words had no effect with an E. And super effective, that's actually as an adjective. So, but yes, still the same. So, effect with an A is a verb. Think varb, and then you'll know. Hey, Bird.
Yes. What is that thing in the corner?
Well, that's actually our logo for our private tutoring company.
Wait.
But you're all, or Eric seems to be getting private tutoring for free anyway.
Yeah, Trig Eric, if that is your real name. Yeah, but my question is, what is the thing in the corner? What is that blue thing? Alta Ipsen, what is that?
That means summit yourself in every language west of the Mississippi Lake.
Ugh, no.
I think it was close. Was I close?
Summit yourself in Latin, but it's a very loose translation, so don't quote us on that. And it's an application you can download on your computer and on your smartphone that is perfect for academics because it allows you
to outsource your stress to the application. It lets you organize your classes. It lets you put in when you have tests and papers due, and then it'll set up study schedules for you just immediately, and then you can mess around with them from there and customize.
Set goals, track your grades. You put in that you have an essay due on Friday. It'll put in, Monday, write a first draft. Wednesday, write a second draft. Thursday night, final touches.
Yep.
It's great. It's great. And your first month is literally completely free. Yeah. Eric, TLT.
That doesn't make any sense, Eric. I don't understand what you're saying.
Yeah, no, that's right.
It will, I like deplete. Yes.
Deplete's a good word.
Your stress
Must be depleted.
depleted.
It sounds like stress is in one of those tanks, like in Monsters, Inc., that they store the energy on, and then as time, the stress gets depleted. You ever watch that movie?
Yeah.
Monsters, Inc.?
Yeah.
Good. Because what they figured out was that...
I was actually its babysitter for a while, so I would watch it when its parents were gone.
Second drafts. Psh. Who does second drafts? Good writers do. Good writers do second drafts.
Ooh, very nice, Bird.
Ah, that's me. I'm Bird. I fly. My Twitch account is messed up. I can't see emotes or see my handler. Well, we can see it. So if that helps, I don't know.
It's all about the tutoring.
You know it's all about the tutoring. About the tutoring. No.
I don't know what you're singing.
It's the Meghan Trainor song, all about the bass, that bass, no treble.
Oh.
But it's all about the tutoring. The tutoring.
I don't know that song.
No classroom.
Oh.
No, classroom's good too. All right, I have a child. I must tutor. I must leave.
Yes. I have no child. That's from Monsters, Inc. Remember the monster with all the arms, and it went in going. Blah, 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 blah.
I do like that.
Do you?
Yes.
Okay. Hey,
Have fun. Not too much fun.
Eric. What do you want? Okay, also, everybody else aside from Eric, feel free to ask questions. You can type them in the chat. You can also not type them in the chat. But I'm happy to do a public private set, a public showing of a private tutoring session I'm doing with Eric TLT. That's also fine. Depends. Most of Brady's students are online. Most of mine are in person. Math on Nerdish SAT. Yeah, so you want me to just hop through the questions? I can just do the questions. That's cool. It was SAT 1, correct? I think it was. So let's do it. Do you want the no calculator or the calculator section, Eric? Ow. Section 3. Awesome. Let's do it. Do you want number 1? Do you want number 1? You want number 2? You want number 3? Where do you want me to start? I'm happy to skip the ones you don't want. It does not matter to me. Two. Okay, so let's start with 2. Oh, yes. Okay. 7, 3i, negative 8, 9i. 7, 3i. 7, 3i, negative 8, 9i. So, how do you feel about imaginary numbers in general, Eric? Do you know how to deal with I squared? Do you know how to multiply? Do you know how to do stuff like that? Or are you just starting from about 0 with imaginaries? Because I could just teach you how to do this problem specifically, or we can talk about imaginaries in general. What would you like? I'm going to start doing this one, and if you don't understand something, let me know. It's a thing times another thing, so we're going to multiply them together. Okay, so you know sum. So we know that I is the square root of negative 1. So I'm just going to write this real quick. I equals I, sure. I squared equals negative 1, right? Because if I is the square root of negative 1, then if you square it, you're going to get negative 1. So I squared is negative 1. I cubed. Well, I cubed is the same thing as I times I squared, because that's I to the first times I squared. You use product rule. I cubed is the same as these two, but this is just I, and I squared we said is negative 1. So that means that I cubed is negative I. Please let me know if that doesn't make sense. I to the 4th is the same thing as I squared times I squared. If you're not familiar with exponent rules, this won't make sense, so we should do those first because those are more important than imaginaries. Here, I squared times I squared is the same thing as I to the 4th. So I squared is negative 1 times I squared is also negative 1. Negative 1 times negative 1 is just 1. That's very important, because then we go to I to the 5th. Well, I to the 5th is I to the 4th times I, right? So I to the 5th is this stuff. I to the 4th is 1, so whatever, and times I. So you're just back to I again. So this you do need to remember for the test. You might get lucky and not need to know anything but that I squared equals negative 1. But I would recommend remembering this order of things. I is just I. I squared is negative 1. That's super, super important. Then I cubed is negative I to the 4th is 1. And then it repeats. Who's calling me right now? Oh, such a bad time. Okay. So with this in mind, let's do this thing. we have to FOIL here. It doesn't matter that there are i's here. We can treat them like variables. They're just x's until we get to the end. So we're going to FOIL. We have negative 56. Outside terms are plus 63i. Inside terms are minus 24i. Last terms are plus 27i squared. Make sure you don't forget the I squared, or remember not to. Unless you forget, in which case you're cooked. So let's combine the middle terms. Negative 56 plus 39i plus 27i squared. Now if you notice, in the answer choices, there's no I squared, or at least not in the right answer. What we need to do is realize that I squared is negative 1. So we are going to replace, so knowing that I squared equals negative 1, we now have negative 56 plus 39i minus 27, because that I squared has become a negative 1. Then we combine like terms, and we get negative 83 plus 39i, and that should be our answer. Eric, does that make sense, that process there? That doesn't, oh, it's plus. Okay. Well, we just did multiplication. Now let's do plus. Seven plus 3i plus negative 8 plus 9i. Okay, so that makes sense. Just don't do what I did and do multiplication at all, because that's not what this question wants. For this, we just add like terms. So 7 and 8, or 7 and negative 8 go together, so we get negative 1. And then the 3i and the 9i go together, and we get 12i. That's the answer. Nothing else to it. Does this make sense? This is about, so this is, yes, A, yep. There's not a lot going on in this question. It's just I is treated like any other variable because you're not actually evaluating anything. It's just I, just another variable. Cool. Number 3. Okay, let me just erase this. Never mind. Wait, so you don't want number 3? Number 4. Okay. Kathy is a repair technician at a phone company. Each week she receives a batch of phones that need repairs. Ah, yes, okay. This is the bread and butter of the SAT. 3 is C. 5M. Yeah. Yeah, you're right about number 3. Okay. Kathy is a repair technician for a phone company. Also, for those of you watching who are not Eric, we are on SAT number 1, so you can find that on the College Board website or basically anywhere. Not basically anywhere. Most places you can, but it's pretty easy to find if you know what to look for. What's that? Okay. Kathy's repair technician. She receives a batch of phones that need repairs. The number of phones that she has left to fix at the end of each day can be estimated with the equation P equals 108 minus 23D. P equals 108 minus 23D. P is the number of phones left. Is that going away? Pretty much. To fix. That is very important. And then D is the number of days she has worked that week. Number of work days. Then 6. Great, sounds good. Okay. The question is, what is the meaning of the value of 108? Okay. What is this? Well, let's think about this. This is the number of phones left to fix. She fixes the same number of phones every day. Yeah? So if we're going to write this as, well, let's think about it this way. She has this many phones left to fix. If she hasn't worked yet, right? She has worked 0 days. This basically goes away, right? There's no 23, there's no minus, it's just 108, right? So 0 days means that P equals 108, which is the number of phones left to fix. So 108 is the number of phones that she has to fix at the very beginning, however many phones she got in the first place. So it does not mean that she'll complete it in 108 days. It doesn't mean that she'll... So yes, it means that she will start each week with 108 phones to fix. It's not her rate of change. This is... what is that called? Interpreting equations. That's what you're doing. Okay? In a lot of this test, you're building equations. In a lot of this test, you're solving equations. And a lot of this test, you are interpreting equations. This is interpretation. If we were to rewrite this equation in y equals mx plus b form, we get P equals negative 23D plus 108. So then if we're going to graph this, 108 is our y-intercept, and then we have a slope of negative 23D. So this is D, this is P, that's our slope, right? So she's got 108 phones to fix, and then the next day so this 108 is her starting point, yeah? And then let's ask this question. What does the negative 23 mean? Well, it's slope, right? So it's however many phones so this is the number of phones she has left on the y-axis. So after 1 day, she's gone down 23 phones. And this is, she's gone across 1 day. So what the minus 23D is how fast is she repairing the phones? She repairs 23 phones every day. That's her rise over run, or in this case, her decrease over run. Yeah? Fixes 23 phones a day. Perfect. So, interpreting equations is a big deal. Things make more sense when they are in y equals mx plus b form because you know what those things mean. You know this is the y-intercept, but you also know that at this point, 0 days have passed. That's the whole point of this thing, is when you plug in 0 for your x value, the 0 days, or d, right? You plug in 0 for this, you just get number of phones left is 108. That's how you solve this. Okay, number 6. Oh, good. This is exactly the same idea. It's another question about equations. We are interpreting this equation now. H equals 3a plus 28.6. Let's do it over here. H equals 3a A plus 28.6. So answer is, oh sorry, so number 4. Yes, number 4, the answer is B. Number 6, H is the height. Okay, that's easy enough. So the height is a function of that, or a function of A, in inches. In terms of the boy's age, so this is age. What is the estimated increase in inches of the boy's height each year? Okay, so how much taller is the boy getting every year? What is the increase in H per year? That means slope. Right? Now you could do this a different way, but the answer is going to be 3. Because he seems to start out at 28.6 inches, right? That's it's like a baby, right? A baby's more than a foot long. And then he grows 3 inches every year. That's what's going on here, okay? Another way to do this is they ask, what is the estimated yearly increase in height. Another way to do this, to brute force your way through if you don't understand the equation fully, is to say, well, they want an increase every year. So what I'm going to do is I'm going to say, well, when A is 2, if A equals 2, then H is going to be, plug in 2, get 6, 34.6. Yeah? And then, let's say now every year. So the next year, A is 3. So that means that H is going to be 9 plus 28.6, which is 37.6. Therefore, the change in height is an increase of 3, which is the same thing as the slope. Okay? So, when you have equations in y equals mx plus b form, you know slope and you know y-intercept. The y-intercept is the value of the y thing when the x thing is 0. So whatever the context is in your problem, that matters. The slope is the same, is comparable. Okay? Rise over run in context. 7. Okay. Often the more complicated, if you see really complicated equations, you probably don't have to do that much work. Just a nice rule of thumb. Because they're not testing you on your ability to do insanely complex mathematical equations. That's not what they care about. Remember, this is just a college readiness test. You don't have to do the most insane equations to be able to graduate in high school and go to college. So this one has a giant equation, but then it says, which of the following gives p in terms of the other variables? So I'm not going to write this all out because I don't need to. Let's say we have m equals xy to the t power plus 4ab all over 3x to the y power times 4 log of n times p. Okay? That's our equation. And then it defines all the variables for you. Great, which is worthless information. And then they say, give us p in terms of the other variables. So that just means solve for p. You want p equals. You want p isolated. So how do you isolate p from this big fraction in this case? You don't have to freak out. Multiply by the reciprocal, right? If we were to have m equals 1, or let's say 2/3 p, and you wanted to isolate p, you multiply both sides by 3/2. That cancels. You just get p equals 3/2 m. So in this case, we'd have the opposite of that. P equals 3xy 4 log n all over xy to the t plus 4ab times m. We multiply by the reciprocal. Is the answer B? Yep. There you go. Right? So it's a big, scary equation. Rule of thumb is you probably don't have to solve it. You're just isolating a variable. So that's a very common question type as well. They say, here's this big equation. They define all the variables for you, and then they say, well, give us the equation, same equation, but solve for this in terms of this other thing. So that just means isolate that variable, and you know how to do that because you know how to manipulate equations. Yes, so you're saying that you divided by p on both sides and then divided by m on both sides and then took the reciprocal? Yeah, you can do that. I would just recommend that you leave p where it is, and then you say, I want to get all this stuff away from p. So you multiply by that big thing's reciprocal, goes away, it's on the other side now. Both methods work. I find mine a little bit clearer. What's the next one you want me to do? Yeah, no, I totally get what you're saying. I think that I've seen too many people make the mistake of just dividing by p and then thinking p equals whatever's on the other side, and that's not the case. But your idea is correct. 11 and 12. Okay, so 11 has to do with chicken and beef or something like that, right? In the equations above, B and C represent the price per pound in dollars of beef and chicken. Okay, so B equals, and 10. Okay, we'll get back to 10. No, we're going to do number 10 first because it's a little simpler than 11. We have... Okay, cool. So we have 3x plus 4y equals negative 23. And we have 2y minus x equals negative 19. Okay. I don't like elimination. I like substitution. Broccoli and carrots. Got it. Sure, we can do broccoli and carrots. I'm perfectly happy with that. I'm going to just make this a little clearer to read. 3x plus 4y? Yeah. 3x plus 4y. Okay. What are we going to do here? Some people like doing elimination. I don't like elimination because substitution is usable in all situations with systems of equations, and elimination isn't always. So I'm going to solve for x in this one. So I'm going to say, now we have negative x equals, I'm going to subtract 2y from both sides, negative 2y minus 19. And then I'm going to multiply both sides by negative 1. I get x equals 2y plus 19. Dang it. Good point. Good point. How long is this lag? Whatever. All right, so we'll have three questions going on at once. Okay, I'll do number 10. G of 10 equals ax squared plus 24. G of 4 is 8. Why did I do that? I'm really losing it. Okay, G of x. G of 4 is 8. We want G of negative 4. Yeah? You got B. Okay, this is how I would do it. This is a system of equations. That's what this is. Okay? You know that G of this is your function, and you know that G of 4 is 8. So that means if you plug in 4 for x, then G of x will be 8. So we can rewrite for this one, these two come together, and we get 8 equals a times 4 squared plus 24. I'm not going to check 9. If you want to check it yourself, then just plug in your answer choices into the plug your solution into each of the equations, and it should work. So I will do this, and then I'm going to subtract 24 from both sides. So what I'm doing is I'm plugging in 8 and 4 for the respective variables here, right? G of 4 is 8. So that means when x is 4, y is 8. So I have 8 equals this. Now I'm isolating a, so I can figure out what a is. Does this make sense so far in number 10? Subtract 24, we get negative 16 equals a 4 squared. Oh, okay. Well, this is negative 16 equals a times 16. So we divide by 16 on both sides, and we get a equals negative 1. Yeah? So if a is negative 1, kind of. Okay. So this is called function notation. When you have g of x and kind of yes, like you don't want me, you got it now. Great, awesome. So always, this is your x value, and then whatever this whole thing equals is your y value. Okay, so that's what we did. Solved for a, and now they want to know what is g of negative 4. Well, now you know that a is negative 1. So g of negative 4 equals negative, because we know a is negative 1, x squared plus 24. Sorry, this should be, so I'm going to plug in 4 now, or negative 4. So we have g of negative 4 equals negative 4 squared plus 24. So that's negative 16 plus 24. So that's 8. That's your answer. Okay? A couple steps to this one. Okay, now we're on the, what did you say, broccoli and carrots? We are on to broccoli and carrots. So we have, you do want number 11, yeah? 235 plus 0.25. 235 plus 0.25x, and carrots equals 175 plus 40. 175 plus 0.4x. Yeah? Those are our two equations. Now, the context of the problem is x is the weeks after July 4th, July 1st, whatever. All right. The question is, knowing that X, this is weeks after July 1, what was the price per pound of beef when it was equal to the price per pound of chicken? That's important. No. During last summer is not a non-essential. We have in the equation above, that's a non-essential, right? In this thing, now we're going to hit the non-essential, we're going to hit the independent clause. B and C represent, so that's our subject and verb, right? B and C represent the price per pound in dollars. That's a non-essential in dollars because it's in the commas. B and C represent the price per pound in dollars of beef and chicken, respectively, X weeks after July 1st during last summer. So the independent clause, or the main part of the sentence that isn't offset by commas, is B and C represent the price per pound of beef and chicken X weeks after July 1st during last summer. Couldn't it just be after July 1st, though? Yes, it could be. But when we talk about non-essentials, it's pieces of the sentence that don't need to be there that are offset. So don't go too far. Technically, all we need in this sentence are B and C represent the price per pound, right? That's all you need. B and C represent. You have your subject and verb. That is technically the independent clause. But there's other stuff. Like if we say, I walk to school, this is your independent clause. This is technically a prepositional phrase because that's a preposition. But it doesn't matter. It's not a non-essential. So during last summer is not a non-essential. It's a prepositional phrase, actually. But it does need to be there because it is not offset. You have to offset non-essentials. All right. That is a good question, though. I like that question. I like where your mind's at when you're doing math, because that's where mine is at. Ugh, weird. Okay. So the question is, what is the price per pound of beef when it is equal to the price per pound of chicken? No problem. Price per pound of beef when it is equal to the price per pound of chicken. This is a weird inside-out type of question. So you actually have to work backwards. So this is the price per, sorry, not beef, my bad, broccoli. This is the price per pound of broccoli. Yeah? That's what we're looking for. And the question is, what is that price when it is equal to the price per pound of carrots, which is this. So now we're saying, what is B when B equals C? Now, if you look, we have a system of 3 equations and 3 variables, B, C, and X. So we can solve for all 3 of them. This is pretty straightforward, though. You can plot. I'm going to get new markers. Give me a second. These markers are done for. Got the new 3. Okay? This is going to be awesome. So if B equals C, that means that we can just set these 2 things equal to each other and these 2 things equal to each other. So this just brings us, wow, that's so thin. 2.35 plus 2.25x equals 1.75 plus 0.4x. Does this idea make sense? Yes, so you set them equal to each other. Yes, exactly. And now we solve for x. So solving for x means we're going to subtract 0.25 from both sides. Sorry, 0.25x. So that'll give us 2.35 equals 1.75 plus 0.15x. Then we're going to subtract 1.75 from both sides. This will be 0.6 equals 0.15x. Divide by 0.15 on both sides. This will give us that x equals 4. Notice, that's not an answer because that's not the question. Luckily, sometimes they do put an answer that is an intermediate step on your way to getting the right answer because you're not paying attention and answering the specific question. They said, what is the value of the price per pound of broccoli when it equals the price per pound of carrots? So what we just found, x equals 4, all that is the number of weeks after July 1st that causes these two to be equal. Now we just need to solve for b. So we take this b equals 4 and we plug it in right there. That was probably the worst way to draw that. So we're going to get that b equals 2.35 plus 0.25 times 4. We'll get that equals 2.35 plus 1. So b equals 3.35. And that's our answer. Does that make sense? Please let me know if it does not. This is tough, but it's not impossible. You want to be working your way through the problem very methodically. So they gave you a system of equations. They told you what is b when b equals c, which is a weird way of saying it, but you say when b equals c. Great, so I do that. Awesome. So this makes sense. Next one. Could you also plug into c? Yes, you could, because we said that b equals c. So you could plug in, I think you meant plug into x to find c. Yes, you can solve for c that way as well. Or for b, because b equals c, so it doesn't matter. Next question. Oh, actually, just kidding. We are now out of time. But I'll see you tomorrow. Keep giving these guys a shot. Eric, I know that it definitely, I think that we're helping you, otherwise you wouldn't be here. But what I recommend is going through the given answers for these questions that you don't understand, and hopefully they will jog your memory, because when you're learning for the SAT, 12 seems confusing. Yes, it probably is. What is 12? Well, it's confusing, but it's actually very straightforward. There's very little work that needs to be done. It might help to draw a picture. Try drawing a picture. If you're dealing with graphing stuff and they're describing something that's confusing to you and you're having trouble picturing it, draw that picture. It will help a lot. You want to outsource as much of the work as you can to the paper and to your calculator. Well, more to your paper. Yes. So here's what I'm saying to you. I want you to tune in every night that you can for sure. But, and I know that a lot of this stuff is just, you've forgotten it because you are being tested now on stuff you learned a couple years ago and even 4 or 5 years ago, and you just haven't done it, and so you need to remember. But the explanations for these problems on this test do exist. They're on College Board. You can find them. I think you just do SAT number 1 answer explanations. You'll find them. They will explain the things. They don't explain them super well because it's all written down, but it's okay, and it might be good enough on some of the problems to jog your memory as we're doing, okay? And ideally, you can do that as much every night. Ow. Oh, gosh. Did you hear my hip? I don't know if you heard that on the thing. But, yes, I'm happy to keep going. I just want you to start practicing learning stuff by finding stuff that's written, because number 1, it's good for your reading comprehension. But number 2, you're practicing figuring things out without the way that you're most comfortable learning, it seems, which is in person and visually like this. With reading, it's not quite as visual because it's all written in lines, so it's a little bit harder for you, but that's what you need to practice because that's where you're less comfortable. So practice that. You'll figure out some math concepts without needing to watch us, so you don't need us as much. You want to just do everything you can to do better on the test, right, and learn math and everything else. Although math seems to be your current thing going on. Okay, see you tomorrow, and have a lovely night.